so this was our initial data set, the one in orange. And from here, our independent variables were holiday flag, temperature, fuel price, CPI, and unemployment. And we wanted to see the impact these variables had on the weekly sales of a Walmart store, which makes the weekly sales our dependent variable. So, after doing the descriptive statistics and analyzing each of our variables, we then proceeded to do our multivariable analysis. And on our first try, we found out that our predictive model only explained about 2.468% of the weekly sales, which is very low, and it was lower than we were expecting it to be. However, the significance F value suggested that there was a very small probability that the weekly sales could be explained with a model with no sales variable, like a intercept only model. So our model, even though it only explained about 2.468 of the weekly sales, is better than a intercept only model, so that was a good sign. We then saw the coefficients for each variable, and also we wanted to see how each variable was significant or not to describe the weekly sales. So for this, the p-value, we analyzed if it was less than 0.05, and the only ones that were smaller than 0.05 were holiday, CPI, and unemployment, which makes them significantly describe the weekly sales. So because of this, we decided that it was a good idea to make another model with just these three variables that were significant to see if there were any improvements on the initial predictive model that we did. So that's what we did next. We took holiday flags, CPI, and unemployment, and the weekly sales, and we did another multivariable analysis, hoping that the adjusted R-square would improve, even if it was just a little bit, but it didn't. It used to be 2.468, and then it was reduced to 0.434, and it was still better than a intercept only model. So even though it was a little less, we proceeded to analyze the p-value for each of our variables, and still they had very small p-values, which makes them significant enough to describe the weekly sales. So at the end of our analysis, we realized that if the holiday flag, if it was a holiday, then weekly sales will increase by this amount. If not, then they will decrease by this amount. And then because it is a dummy variable, meaning it was either 1 or 0, the only numbers in this column. And then for CPI and unemployment, of course, if unemployment increases, then weekly sales are expected to decrease, such as the consumer price index. And this is what we got. So that was the end of our analysis. And in the end, we decided to compare our model with the estimated sales we will get with the coefficient and the values of the data set versus the actual weekly sales. And this was the result. We did this scatter plot, and we could perceive that there is a very significant dispersion. We can see many points that are scattered really far away from the diagonal line, which confirms that it is not that our model, it's not the best fit in the prediction versus real sales. So that was our conclusion. And even though it was not the best fit for the model, we will also need to consider that sales levels are very difficult to predict, and it is one of the major problematics at the time of planning demand and in the logistics aspect. So that is a variable to consider. And in our recommendations, we also wanted to make sure that Walmart can consider different variables that can impact the sales, like marketing, among others. So that was our analysis for our capstone project.